Sometimes you have to compare decimals or fractions. Basically, which one's bigger? Are they the same? So we are going to insert greater than, less than, or equal to in each one to make it true. One, we're going to compare 1/5 with 0.25. Which one's bigger, or are they equal? How are you going to know? Well, you're going to change 1/5 to a decimal, or you change a decimal to a fraction, whichever one that you want to do. I'm thinking because we're dividing decimals, we're dividing fractions to make decimals, we're going to divide. So 1 divided by 5, you can also multiply it by 20 to figure out what it is, but I'm just going to do dividing. So 0.0. All right, this one's going to be sort of kind of nice because it's 2. So this one is 0.2 and this one is 0.25. So which one's bigger? 0.25. So 0.2 is less than 0.25. Two, 0.7 repeating, or 7/9. But we're going to take our fraction and we're going to divide it and see what we get. 7 divided by 9.0. My decimal is going to be here. Okay, so 9 times 7 is 63, with 7 left over. Bring down to 0. Again, 7, 63. Bring down the 7, and we bring down the 7. As you can tell, it's going to keep repeating. So this is 0.7 repeating. So they are equal. They are the same representation. 0.7 repeating is 7/9. Three, 1/2 and 0.54. And I probably think all of you probably know that 1/2 is 0.5. And if not, if you divide it, you'll get 0.5. So 1/2 is less than 0.54. We'll look at one more. 0.72 and 5/7. Okay, let's divide 5/7. So 5 divided by 7.0. That would be 0.7 is 49. 1, whoops, 1, bring down to 0. That would be 0.1. I can stop right now. Why? Because if I compare them, this is 0.71 something. I haven't finished it. I don't know if it ends or not. Well, it doesn't end. It's going to go on, but I already know that this one's bigger. And then along the same lines, they can ask you this. Rate these numbers in order from smallest to largest. The one thing I caution about this is that watch the words in your problems, because it can say largest to smallest. So just watch what they're asking you to do. I'm saying let's do smallest to largest, but they could go backwards. So make sure you really read what they're telling you to do. Okay, so let's do this one. 1.26, 1 1/4, 1 2/5. And we want to go from smallest to largest. All right, 1.26 is awesome. It's already decimals. 1 1/4, 1.25. 1/4 is 0.25. If you weren't sure, you can divide it. And that would be a 2, which is 8. Subtract 2, bring down to 0, and that's 5, and that's your 0.25. And then the next one, 1 point, what's 2/5? Let's see, 2 divided by 5 is going to be 0.4. So it's 1.4. So we have 1.26. Whoops, sorry, 1.25 and 1.4, smallest to largest. Which one's the smallest? Well, that would be this one, which you write as the original problem. Then it'd be this one, which is 1.26. And then the last one, 1 2/5, would be the largest. So when you see them, just put them in the decimal form and they can compare it by decimal form. All right, question before I add a page. We got one more thing to talk about in this section and then we're good.
Would it, oh, never mind. You put the notes up. You'll put the notes up later, right?
Yeah, they'll go up later.
Okay, never mind then.
You sure?
Yeah, I had just gotten up to use the restroom, so I missed problem 5. I was gonna ask if you could do another one, but if not, it's okay.
Oh, I could probably do another one. Hold on, another one. I actually have another one. I can do another one. Let's do another one. 6.
Thank you.
You're welcome. Okay, same thing. So I'm just going to put smallest to largest. So writing in order from smallest to the same directions as the last one. You can't see it, so I want to write it again. So we're going to write these as smallest to largest. So we have 1/3, 0.302, and 3/8. Okay, so the decimal form is fine. We just need to put the other two in decimal form. So 1 divided by 3. That means, okay, so decimal goes here. I have 3, which is 9. I have 1. It's going to be another 10, which means another 3, which is 9. And it's going to keep on going. So this is going to be 0.3 repeating. Just remember that means 0.333 da 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 da. Just so we could compare them. I'm putting that down. All right, then we're going to do 3 divided by 8. 0.0. All right, so 8 times 3 is 24. So 0.3, 24, which is a 6, 60. 0.3, then it would be 7 is 56. And I think that's all we need. It's going to keep going. Well, no, actually, it's going to end right here. Never mind, 0.35. So 0.375. All right, we want to go in order from smallest to largest. So my smallest number is actually the decimal one, 0.302. What's my next smallest one? Well, if I compare 0.333 and 0.375, that's smaller. So 1/3 is smaller, and then 3/8 would be the biggest. And that would be the order. So like I said, get them all decimal form. And then you compare it with decimal, which one's bigger, which one's smaller. Okay, I'm making a new page. Last little part we can talk about, and that's order of operations. Okay, simplifying expressions. So they're going to be expressions with decimals. We're looking at decimal expressions, how to do them. And you have to think about the order of operations. That's what you want to think about. Don't forget what comes before what. Okay, so 1, I have negative 8.69 times 3.2 minus 1.8. So order of operations says I have to do the parentheses first, right? So 3.2 minus 1.8. And I get 1.4. So then really what my problem is negative 8.69 times 1.4. So now we're back to multiplying our decimals. So I know the answer is going to be negative. I'm going to put a negative to remind me. I'm not going to put the negative in my problem. And I'm going to go 8.69 times 1.4. Now we get to talk about multiplying again. It's awesome. Okay, 9 times 4 is 36. 6 times 4 is 24. 25, 26, 27. 8 times 4 is 32, 33, 34. Add a 0. 1 times 9 is 9. 1 times 6 is 6. And 1 times 8 is 8. Okay, let's add down. 6, 16, 10, 11, 8, 9, 10, 11, 12. Okay, remembering, I'm going to put it over here. I remember it's a negative, but I got to put my decimal in still. Where's my decimal place go? Well, I have 2 decimal places here and 1 here, which means I got to go in the back and I got to move it 3 decimal places. I'll do it down here. 1, 2, 3. So my decimal in my answer is going to be here, negative 12.166. That all right? Questions?
You lost me somewhere while you were multiplying, like the 8.69. I would have thought that you would have put the 1 like under the 8 just to match the decimals and maybe added a 0 to the end of the 4 to
Okay, so
multiply.
when you multiply, you don't ever line the decimals up. That's only when you add and subtract. When you write everything to the left, they should line up to the left. Oh my gosh, my thing won't turn on. They should line up to the left. Don't ever line the decimals. The decimals, when multiplying, you have to add how many decimal places that you have in total, and that's how many you move the decimal place over. You don't want to do 8.69 times 1.4. That would be that would be wrong. You might do it and get the right answer, but it's still not right. You want to line it up to the left. The only time you do this is if you're adding or subtracting. Then you have to line up your decimals. Okay.
Okay, thank you.
2. Let's look at this one. Negative 0.7 squared. It's been a long time since a square, plus 2.1. All right, a square just means 2 of them. So what it really is negative 0.7 times negative 0.7 plus 2.1, because we have to do this first because it's the exponent with parentheses, right? All right, so number 1, I know a negative times a negative is a positive, so I'm going to put a little plus here. I'm not going to worry about the sign. I know it's going to be positive. And then I'm going to go over here and I'm going to multiply 0.7 times 0.7. Now this time the decimals line up only because they have the same decimal point. But 7 times 7 is 49. I have to move 2 decimal places. That's going to be 0.49. This is positive 0.49 plus 2.1. And when I add that, now I'm going to line up my decimal places. 2.1, 0.49. Because when we add and subtract, we line up our decimal places. I'm going to put a 0 here, and I'm adding. So 9, 5, 2, decimal place 2.59. Yeah, these problems bring everything back. Multiplying, dividing, like how do you do them? How do you add? How do you subtract? How do you multiply? Everything. Just remember a square means two of them being multiplied.
Will there ever be a time where the square's on the inside of the parentheses?
Yes, but if it was, there's a little bit of, see if I can explain this to you. Because it's a little bit of an answer, a question, but I like it. All right, so let's say I have this like that, right? That's totally different than saying this. And I'll show you why. This is saying only to square the 0.7. This one is saying negative 0.7 times 0.7. This negative is not with this 2. They are not attached to each other. This is like a -1 times. So the only thing that you're squaring is a 0.7. You're not squaring a -1. I know that's a tough question because it's a pretty advanced question, but that's what it means. So it means something completely different. You wouldn't see that yet. You'll see that probably in your next class because that's when you really learn it. You learn it intermediate. I mean, development math 2, what that means, a negative without a square. So you're a little bit ahead of yourself, but yes, you'll see it. It just means something different. You won't see it yet. All right, let's do one more. 6.2 plus 3.4 times 4.5 minus 1.3. So we have 2 sets of parentheses. Of course, we do our parentheses first, correct? So we're going to simplify each parentheses first. So the first one's adding. 6.2, I add up my decimal places. I'm going to add down 6, 9. So my first parentheses, I'm going to put like this, is 9.6. Now I got to do my second parentheses. This is minus. So again, I have to line up my decimal places, 4.5 minus 1.3, and I'm going to subtract, and I get 2.3, 3.2. So my problem now is 9.6 times 3.2, and now we're going to multiply them. So 9.6, 3.2. Remember to line it to the left, although the decimal places line up this time because they're in the same spot, but you don't have, you always line up to the left. Okay, so here we go. 6 times 2 is 12. 9 times 2 is 18 plus 1 is 19. Add my 0. 6 times 3 is 18. 9 times 3 is 27 plus 1 is 28. I'm going to add down 2, 17, 8, 9, 10. Carry the 1, 3. How many decimal places do I move my answer to? My decimal is going to be, there's 1 decimal place here, and there's 1 decimal place here. That's 2 decimal places, so I'm going to move it over 2. So my answer would be 30.72. So basically, this is just bringing everything you've done together. Adding, subtracting, multiplying, dividing. And we have one more thing to do. And it's geometry. Yay, geometry. All right, so we talked about circumference. We did circumference the last time. This one, we're going to talk about the area of a triangle. And why now? Because we also can do decimals for area of a triangle. And actually, it has a decimal as part of the answer. It actually has fraction as part of how to find the answer. So let's look at finding the area of a triangle. Anybody remember what the formula for the area of a triangle is? I like to draw a picture.
Isn't it like base times height or something?
It's close, it's close. So the area of a rectangle,
Times width.
yeah, it's 1/2, right? So area of,
Oh, width times height.
yeah, length times width, base times height. They call it base times height for a triangle, so I'll call it base times height. Okay, so base and height. So if I wanted to know the area of a rectangle, ugh. We usually do length and width for a rectangle. We use base and height for a triangle. I'm not sure why. Why we don't use the same thing, I don't know. But anyway, I'll call it base and height because we're trying to show you the area of a triangle. So area of a rectangle with a B and a H would be area is B times H, which is we know as length times width. Same thing, just different letters. But a triangle, to do a triangle, if you make this diagonal line, every rectangle has 2 triangles. That means the area of a triangle, of one triangle, is only going to be 1/2 of the area of a rectangle. So the area of a triangle is 1/2 base times height. And we do write it in lowercase letters, but I wanted to show you it's the same as that, base times height. So if I have a triangle, I need the base, I need the height, and I multiply it by 1/2. And that's sort of kind of why it's in this section, because we have 1/2, which is a decimal and a fraction all together. Okay, so I am not the greatest artist, so hold on here. Anybody know this means? This means that it's perpendicular. Well, actually, I don't care about perpendicular. This means 90 degrees, this little symbol. It also means it's a right triangle. The one thing I have to tell you about the height of a triangle must be the perpendicular height, meaning the right angle part. If you have a right angle, you're also saying that this is perpendicular. Meaning it's vertical. It has to be the vertical part. It has to be a 90-degree angle to be the vertical part. You don't have to worry about that now, but as you go on in math, you're going to worry about it because they'll try to trick you into using different things. Now, only thing I'm going to give you is a perpendicular part. So you're okay. But as you go on, they're gonna do different things and not show you the right height. And I'll even show you an example in a minute. Okay, so let's go. So this is my picture. Same picture. I just drew all over it. This is a right angle, which means it's perpendicular. Okay, so my base is 7 meters. That's my base. And my height has to be here. My height is 2.1 meters. I want to find the area. Area is 1/2 base times height. So what I'm going to do is I'm going to substitute in my base and my height. So 1/2, my base, that's my bottom, base, think base bottom is 7. My height is the perpendicular, the one with the right angle, that's 2.1. I'm going to multiply it all together. You could change the 1/2 to 0.5 and think of it that way, if you prefer that way, or you can leave it the way it is. I like to do, I'm going to show you what I do. We get the same answer either way. I do this part first. I leave the 1/2 for last. And then if I want to change it to 0.5, I'll change it to 0.5. Sometimes, let's say it winds up being, the answer is 9. It's not. Let's say the answer is not 9. The answer is like 10. I know a half of 10 is 5, so I don't have to make it decimal, but sometimes you want to make it a decimal. So I start with the non-fractions first, and then I deal with the fraction last. You can do it any order you want. All right, so I'm going to do over here 2.1 times 7. 7, 14, moving 1 decimal place. So I really have a half of 14.7. So yeah, I'm going to do a decimal for 1/2. I'm going to make it 0.5. So I'm going to do 0.5 times 14.7. So let me go back over here. 14.7 times 0.5. Let's figure out what that is. 7 times 5 is 35. 5 times 4 is 20 plus 3, 23. 5, 6, 7. Now I'm going to add my zero. Then I don't need to do anything else because the other one's 0, right? How many decimal places is that? That is 2 decimal places. So I'm going to move it to 2 decimal places from the left like that. And my answer should be 7. Oh, no, I'm writing it there. Hold on. I need more room. Let me do it like that. Let me put that here. Area is 7.35. Now, very important. Area, you multiply 2 dimensions. So it has to be meters squared. Every area is squared. Meters squared. A half base times height. A half base times height. Let's try another triangle. I'll draw a different kind of triangle. But it's going to be a right triangle. So let's say this is 12 centimeters. And this is going to be 10 centimeters, 10, not 12, 1.2. Let me do decimals, that'd be nice. 1.2 and 10.3 centimeters. And we want to find the area. So the area is a half base times height. Now, this is my base, because that's my bottom base, right? This would be my height because it's a perpendicular. This is my H. So area is a half base 1.2 times height 10.3. I do the non-fraction first. I do my decimals first. All right, so 10.3, 1.2. I also put the longer number on top. I think I told you that when we did it before. All right, 3 times 2 is 6. 2 times 0 is 0. 2 times 1 is 2. Add a 0. 1 times 3 is 3. 1 times 0 is 0. 1 times 1 is 1. We'll add down. 6, 3, 2, 1. My decimal, I have 2 decimal places total, so it has to go here. So what I really have now is 1/2 12.36. So I'm going to multiply that by 0.5. So 12.36 times 0.5. Six times 5 is 30. 5 times 3 is 15. 16, 17, 18. 5 times 2 is 10 plus 1 is 11. 5 times 1 is 5 plus 1 is 6. And I have 3 decimal places. I have 1 here. I have 2 here. So I'd have to put my answer here. So my answer is area is 6.18. Now I don't need the 0. You could add it, but you don't need it. Centimeters squared. And done. And that's the end of that section. And then we have about 12 minutes left. I want to go over what's going to be your tests, if you want to know. basically everything we've done, but I can narrow it down a little bit. Okay? Any questions before I do that? Okay, some type of problems that you're going to see in your test. So test review. I don't have time to do all the ones on mine, but I'm going to pick out the ones I think are the ones you need to know the most. I mean, I'm going to tell you what's on it. Okay, number one, you should be able to write a decimal in from words. So let's do an example. All right, so write the decimal number in, this is how it's written in standard form. And you might not remember what that is until you actually see what they give you. They say this, something like this. 32 thousandths. So basically you're writing out the number. How do you write 32 thousandths as a decimal? Well, we know, just review, this is my 10th spot. This is my 100th spot. And then that's my 1,000th spot. So I know it's 3 decimals. So 0.32 thousandths. So tenths, hundredths, thousandths. That's your answer. That 2 had to end at the 1,000th spot, 0.032. That's one of the first things I think we did, is rewriting them as decimals. 2.
That first one, when I was doing my homework, I'm not gonna lie, my brain like did not function with me during that part of the homework. And I was like completely thinking of when we were doing it, just the like ones, tens, hundreds, and thousands. The other way, not with the TH in it, but my brain was not functioning during that homework part. So if you see all the mistakes, I'm so sorry because I was
Oh, it's all
not
right.
using my brain.
It's all right. It's all right. It happens. Look at my brain. Not always there. It happens. But does that make
The ones
sense?
that got me on the home.
Yeah. So you gotta keep track of what place it's in, the thousands place. So if I said, here, let me give you another one. If I wrote 200 10 thousandths. Actually, let me change that for a minute. I don't want 200. I want 200 something. 230. Let's do 230 10 thousandths. Okay. So the 10 thousandths is, say we have a decimal place, right? That's my tenths. This is my hundredths. This is my thousandths. This is my 10 thousandths. So it's actually the 4th decimal place. So 230 10 thousandths. So 0, tenths, hundredths, thousandths, 10 thousandths, 230 10 thousandths. This is my 10,000 spot. So that number has to end wherever it's telling you the spot has to be. 230 10 thousandths. If it said, okay, if it said 12 hundredths. Well, the hundredths is my 2nd decimal place. So that means this would have to end at the 2nd decimal place, which means the 12 just goes 0.12. That's 12 hundredths. But if I said 3 hundredths, that means the 3 has to end at the 100th spot. You have to add a 0 to get to that 100th spot. So sometimes you have to add a 0 to get to the spot you need to be in. Whatever number they give you, that last digit has to end in the spot it tells you to go to. And see if that helps you.
Oh, I see what I was doing. So I was doing the whole ones, tens, hundreds, thousands.
Got it. Yep, yep. Go back and look at it again. I mean, it's still open. You can probably go back and just do them again and fix them and just see how that works. But try to think of whatever spot they give you, that's where that last number of the number they gave you should end. And if you have to add zeros in the front to get there. Okay. Hopefully that helps a little bit. All right. Remember the check thing I did where you wrote a check, right? So I was so happy to find they actually had that as a problem. I made that up myself. Okay. So let's say it says, yeah, it's on the test because, I saw a check. I'm like, oh, we'll put it in the check. So the test. Okay. Write the check for $412.56. Okay. So what you have to do is you're going to put $412.56 in the dollar part. There's always a dollar part of a check, but then there's a line right underneath it where you have to write it out. That's the part. So it's 412, and they don't have dollars. They do 12, and then there's going to be a line. And then it's going to be 56 over 100. That's how you write your change. 56 cents out of 100. So you're going to be filling in the two spots if I remember right. You fill in the money here, and then you're going to write 400, whatever the number is, 412 and 56 over 100 for your cents. Oh, hold on a second. I forgot my most important thing, and 56 over 100, because it's decimals. Remember we talked about the decimal means and, right? 412 and 56 over 100. Make sure you put the and in there.
I say that too.
Mm-hmm. Yep. So they'll give you like, it looks like a little blank check, and you have to fill in the line and fill in the two spots.
Writing checks was actually a required class at my high school.
I love that because how many high schools don't? I had a student who was like an honor student in my class, like super smart. And she got a checking account. She was like 17 working. And she came to me one day and she goes, I really feel really dumb to ask you this, but can you show me how to write a check out? I'm like, don't feel dumb. They don't teach it to you anymore. So I taught her how to do write a check and how to balance your checkbook. So they don't teach it. I'm glad. They should teach us in high school. I'm glad. That's great. In New Jersey, they don't. That's where I'm from. They don't teach us in high school at all. And I don't understand why not. Okay, so write the decimal as a fraction in lowest terms, meaning simplify if you can. So 14.2. All right, so 14.2 is 14. Now this is in the 10th spot, right? 2/10. But I can simplify that fraction. So it would be 14. I can divide both of them by 2. It'd be 1/5. You'll have something like that. Beside basic adding and subtracting of decimals and multiplying and dividing, you will also see something like this, negative 6.239 and negative 6.240. And you're going to ask to do this. Is it greater than or less than? Like fill in, I guess there's a box or something here. I can't remember exactly what's there, but which one's greater than, which one's less than, et cetera, et cetera. Now they're negative. So I really want to highlight this. This is negative. Negative means which number is closer to 0. It's backwards than positive. Because in positive, If this is both positive, this would be the smaller one, but with negatives, it's opposite. So this is the bigger one because it's closer to 0. If I did a number line and I have 6.39 in a negative direction, this would be, sorry, 6.239. 6.239. This would be negative 6.240. So that's that, and here's 0. That is the bigger one. So when they're negative, I want you to think backwards. They're opposite. Okay, I want to try this one. It's a good one to do. Subtract 12 minus 0.0032. So a big number from a really small number. So let's set it up. So remember, decimal places have to line up when you add and subtract. So that 12 has to go here, and then that 0.0032 has to go here, which means I'm going to fill in the zeros. So I have all the zeros to match my number. And then we're subtracting. All right, so this one, lots of zeros, right? So I have to borrow from the 2 to make that a 1, to make this a 10. And then I got to borrow from the 10 to make this a 9, to make this a 10. And I got to borrow from that 10 and make that a 9 and make that a 10. And then I got to borrow from this 10 and make it a 9 to make this a 10. Lots and lots and lots of borrowing. And now I can subtract. So 10 minus 2 is 8. 9 minus 3 is 6. 9 minus 0 is 9. 9 minus 0 is 9. Decimal place. 1 minus 0 is 1. And 1, bring it down. And that would be my answer when I finished that mess of a problem. Six, find the perimeter. And it is a square. It'll tell you square or not square. It'll tell you square. It's a square. So perimeter is all the sides added together. That means that every side is 9.34. I'm writing it in different color because I'm not given to you. It just, you have to know they're all the same. So I have 4 9.34. So either you can add 9.344 times, or I think I'm just going to multiply 9.34 times 4, because there's 4 of them. What am I talking about? Yeah, I'm talking by 4 of them because I'm adding 4 of them together. Or you could do 9.34, 9.34, 9.34, or do it in pieces. Either or, you're going to get the same answer. Either add them all or just multiplying by 4 because there's 4 of them. Okay, so 16, 12, 13, 9 times 4 is 36, 37, and 2 decimal places. So my perimeter would equal 37.36 centimeters. It's not a square, only area is a square. I know we're a little bit behind, but there's one more I really want to do. And the rest of them are basic adding, subtracting, multiplying by tens, decimals. There is a finding the area of a triangle. So make sure you really practice that. The last one I really want to do with you is this one. The diameter of a tire is 30 inches. Whoops. 30 inches. Find its circumference as an exact value and as an approximate. Oh, my handwriting is really going. Okay, approximate value using pi is equal to 3.14. We talked about this, exact versus an approximate, and that was our last class. I just want to make sure we do one more. The first thing is you have to know what a circumference, the formula for circumference is. So circumference is either pi d, meaning pi times the diameter, or 2 pi r. Since they gave us a diameter, we're going to use this one, pi d. It wants it as exact and approximate. So let's do the exact. That's the easiest one. Circumference equals pi. The diameter is 30. All we have to do for this one is rewrite it so that 30 is first and add my centimeters. That's exact. Done. We don't touch pi. It just stays in the answer. Now, approximate would be C equals 3.14 times 30. So now we have to do our multiplying. So 3.14 times 30. That would be 0, all zeros, right? And then we would do, okay, if we add a 0, 12, 3, 4, 9. And then I have 2 decimal places, 2 decimal places. So I'd be over here. So my approximate value is 94.20. You don't have to do the 0. You can put 94.2 if you want. Doesn't matter. Either or is right. Centimeters, one or the other. And that's the difference again between exact and approximate. And everything else we've done recently, I'm looking at. Evaluate an expression will be in there, adding them, subtracting decimals, making a fraction a decimal like we just did, order of operation. And I think I just went over everything. Anybody have any questions or anything? I know we're way past, we're like 5 minutes past, so I'm done, but I'm here and I'll stay on if you have anything.